Nice.
Awesome, awesome. Awesome. Thank you guys so much for joining us. We're gonna wait for a few more people to come in and we're gonna get started. We're gonna get started. But yeah, thank you guys for joining. Thank you so much. I see we have Abel. Nice to see you, Abel. We have a few other people. Um, I actually had a question while we wait for more people to come in. Um, this is our question of the day, right? And you guys can unmute, you can put your comment in the chat. But I want to know what was the most memorable thing you did this summer? What do you think? That is the question for today. What was the most memorable thing you did this summer? Anybody wanna share? Care to share? Alpha, good to see you. Yo, we were just asking, I was just asking a question of the day. And today's question is, what is the most memorable thing you've done like this summer?
Memorable thing.
Yeah.
Oof. I'd say, I mean, spending Eid with my family after 7 years, probably.
Okay.
Yeah. They were able to come and visit me, so I was happy for that.
Nice. Nice. Nice.
Hey Andrea, how you doing?
I'm doing good, man. Yourself?
Pretty good, pretty good. Can't complain.
Awesome. Awesome, bro. Glad that you're here, man.
Yeah,
Yeah.
likewise.
Yeah, hopefully we get some more people in so we can share the system design gospel, right?
Definitely, definitely. Can't
Yeah,
wait.
yeah.
Yeah. I try to share Bailey posts on one of my uh group social network that I use.
Mm,
Um Hopefully people join. Uh
yeah.
Awesome. Well, I say we start it off, y'all. Let's start it off. Well, today's meeting will be, let's start it off. Awesome. Well, thank you guys so much for coming in. Today, right, we're gonna be talking about system design, right? So how do we go from confused to confident in a system design interview? How? That's a great question. That's what we're going to be talking about today. Um, I really want to start off. Oh, this is a brief overview of what we're going to be doing. We're going to try to keep this thing in under an hour. I'm going to give a brief overview of PhiJump and what we do. Then we're going to go over the basics of system design. Then we're going to do a demo, a short, quick demo with Andre, who's a software engineer. And we're gonna do like a group activity and then we're gonna wrap it up. So that's the plan for today. So thank you guys again so much for joining. I would have loved to hear more of what you guys did. Some more people comment about what they did, anything interesting this summer. Um, but hopefully, I can hear we have another session and I can hear a lot more about it. Oh, and also, if anyone is here, they have like specific questions for me, like about their career or something like that. A lot of people, message me about career advice and this and that, and I really try to send people here to these live events so that I can answer every question at the same time, and that's usually done in the wrap up or I can do it while the group activities are going on. I can answer any questions you have if you don't want to go into the group activities. Cool. Thank you. So, and yeah, like I said, feel free to unmute if you have any questions. Feel free to, put your camera on or put a chat in the comment if you have any questions. Thank you guys again. I'm so happy we have everybody here. Um, cool. Okay, we got a few more people. All right, I guess we could keep it simple. Just comment where y'all located. What city y'all in? That's always my go-to since nobody wants to talk about their summer adventures. We'll do that. I need at least 2 people. We need 2 people so we can get started. Houston, thank you so much. Sokujo. I pray that I pronounced that correctly. If not, please correct
No,
me.
no, that's good. That's good.
Thank you. Thank you. Thank you. We need one more, y'all, and we can get started for the day.
What's your name?
My name is Ramel Bailey. Sorry about that. I'm Ramel
Romel.
Bailey.
Okay.
Yeah. Okay. All right. We're not gonna get it. That's cool. Um, well, cool. So I want to talk a little about FiveJump, right? So FiveJump, we started this in 2022, and essentially we support software engineers and people in the tech industry, right? We train and develop engineers to be successful in their careers. We've done different workshops in the past. We have partnered with different companies. We've done a lot of different stuff in the past, and we're continuing to add more programs to what we're doing. So I'm really excited about that. We have an upcoming program coming up that I want to talk to you guys about. And some of the impact that we've had, working with people, we've been able to impact a lot of people, and I'm really, really proud of it, right? Our job platform, if you've ever seen it, if you've ever used it, right, it's been used by over 200,000 people, 200,000 job seekers looking for tech jobs. We've done a lot of workshops over the years. We've had well over 1,500 people. And we've worked with clients, we've worked with people on a really close level, and we've been able to make impact on that, helping people, land roles, land positions. We worked with someone recently. Well, I guess usually people are able to get jobs that are making 6 figures or close to, right, that we work with. And the highest compensation, we supported somebody who signed a very large compensation package. This is over several years. And we're really, really proud of that because I specifically, that guy, he reached out to me, and he reached out because he was an international student, and he essentially graduated from college and had no jobs and no offers. And essentially we had to work really, really hard to make sure he got an offer before he was, forced to leave the United States. And we were able to help him get a job at a top tech company, and boom, he signed an offer for 700. He didn't have a master's degree, just a bachelor's degree. So really, really happy. That was 3 months ago, by the way. In this economy, he did it, right? So we're really, really proud of that. We've worked with different uh people. We've worked with recruiters, we worked with engineers that work at different companies in the past, right? We want to continue to do that kind of stuff. And then I guess the last most important thing I want to mention is that we have an upcoming training program, right? Where we are really leveraging all the expertise that we've developed over the years, where we're going to be supporting engineers who are trying to get tech jobs, right? So we're going to be heavily focused on training people for landing more interviews, right? Where they can get career advice from recruiters, actually gaining in-depth knowledge on, on interview preparation, in-depth knowledge on system design, right? From senior engineers, from people who work at these top companies. Right. So this is something that we're really, really proud of. This is going to be a really good program. I don't think there's any program out here that does this exactly what we're trying to do. And another goal that we have is we try to explain things in a way where everybody understands it, right? We don't want people to walk away not knowing what we're talking about at all levels, beginners and non-beginners. So we're excited for that. If you guys are interested in, this is not a free program, right? This is going to be $997, and it's going to be in the fall, right? But if you're interested in that, if you're really trying to level up your career, check out this link. You can join the wait list, and I put that in the chat. So thank you for that. Cool. Let's get back to it. So yeah, so this is just a program, like I mentioned. It's called Your Next Sweet Job. Okay, cool. So we're here for system design today. But what is system design? Anybody have any comments on it? Any thoughts on what system design is as far as software engineers are concerned? You can put it in the chat. You can unmute anything. Okay.
So I believe that system design is like the name says, it's about designing systems. And now there are two angle of views when talking about designing a system. It can be low level or at the high level scale.
Yeah. Thank you. Thank you. Yeah, that's exactly what it is, right? We're literally designing software systems.
Mhm.
Um and I guess from the definition of it, it's really we're being architects, right? We are in the architect position and we're creating an application and our goal is to meet whatever functional and non-functional requirements that we have, and we want to make sure that, it is as good as possible while meeting those requirements, right? So if we can make it scalable, if we can make it reliable, if we can make it maintainable, that is the goal. But then there's a question of like, why is this important, right? I think we hear a lot about system design and we don't understand like why is this a part of the interview process? Why is this something that I should be concerned with, right? And I think it goes back to thinking about any software app that you've used that actually impacts millions and millions of users, right? Why do we need system design, right? Well, we need it because when we're building these applications that support so many people, so many users at the same time, right, in all parts of the world, in all parts of the country, or all over the world, like I said, right? We need to make sure that our application is continuously up and running and nobody can bring our application down, right? So we see, 2018 Facebook hit an insane amount of users. And I think what's crazy to think about is like they probably had so many fake accounts, so many people scamming on the platform, so many people doing different things that it probably could have been even more users on this application if it wasn't built properly with the right protections, right? So this is a really, really cool part of being a software engineer. Obviously, none of us have to design Instagram, like the entire application of Instagram. It's complex. It's big teams created this. But when we're trying to build something that can scale, we have to think. We got to put our architect hat on. We got to think as a system designer. Um, a lot of you, I'm not sure if you're able to watch this fight, the Logan Paul and the Mike Tyson fight. And this happened last year, I believe. Logan Paul, Mike Tyson had a huge fight on Netflix, and I believe there were like over 50 million people watching it in real time. 50 million people. And again, those numbers could be more or less, right? Over 50 million people were watching this fight live. And a lot of people complained about the quality being very blurry, right? It was buffering or there were different issues with it, right? All of this goes back to system design. All of this goes back to how do we create it? How do we set it up to handle a huge amount of users at all watching this at the same time? And I'm sure they learned their lesson from that experience. But the goal is we want everybody to have a great user experience and not a choppy user experience, right? Or literally the app crashing. That's the worst case scenario is your app just stops working or nobody's able to use it, right? Or data is able to be breached, right? People's information gets out. Those are the worst case scenarios. And we have Prime Video here. I work at Prime Video, and this is so important. I've seen the impact firsthand, right, of a platform that we also have live content. We also have millions and millions of users watching one live event, right? Like the Super Bowl at the same time. And literally, I've seen us go from having a poorly designed system, right? Maybe it was a good system when it was less users, but it was a poorly designed system when we expanded, to the point where we would have to manually um, input data, input information by running scripts, right?
Hmm.
If something was missing. So imagine you're watching a movie, right? You're watching The Rings of Power and like you're in Japan and like your movie's not playing or like your something is missing. You can't actually press play. You're not seeing any options. Literally on my team, right? Besides literally coding, we would have to run a manual script. We would get an alert, oh, this is not working. We have to go run a script just to bring it back up. And it might take a few tries too, right? So this is why system design is important because when you're operating at scale, when you have a lot of people using a platform, there's so many things that could go wrong. Um, yeah, system design allows you to at least even know what's going wrong, right? Knowing what's going wrong is important and being able to fix it, even if it's not the best solution. Maybe you have a really, really cool idea. I'm not sure if any of you have used the app Partiful, right? This is a really popular app now. And I think building these kinds of things, right? If you're a founder or you're thinking about building something, thinking about something that scales, thinking about how it's going to run and reach so many people is really, really important, right? So these are kind of the reasons why we think about system design and this is why it's important. Um, Anybody have any questions on that? Any comments?
No.
Awesome. Cool. So just like I said, right, whenever we're building software that is used by millions and millions of people, things will always go wrong every time, right? There's going to be something that's going to go wrong. The code can be perfect. However, if you don't design it right, or if there is some issues at play, it can still be not the best experience for users, right? If they use it in a way that maybe you don't expect it. One good thing about system design, again, you get to be an architect, you get to be in the driver's seat. And I love that in big tech, you actually get to design systems. It's actually it's a great thing to be able to design systems because I've worked for companies where as an engineer, only one person was able to design anything, and that was the architect. Right. It's great to be at a place where you have the know-how to think like a senior person, right? This is a skill that more senior people tend to have. When you get to think like a senior person, you get to actually make these designs. You get to be in the driver's seat of how this whole solution comes out into play, right? So yeah. So let's kind of dive into it, right? And let's talk about how we can pass more interviews, more system design interviews. So there's a few core things that we need to know when it comes to system design interviews, right? We need to understand the core concepts. These are core concepts of designing system designs, right? That are really going to take place in like architecture in general, all types of software architecture. Patterns, there's a lot of common patterns that come up when designing systems architecture, especially in these interviews, as far as these interviews are concerned. And then technologies. There's modern new technologies that we tend to use to solve different problems, right? Another thing we need to be able to do is we need to know how to present a solution, right? How do we approach an interview? Just like a coding interview, there's a process, there's a step that we have to go through. And we have to continuously practice and work with others on this kind of thing, right? So for the most part, there's about 4 types of system design. Today, we're only going to be focusing on product design and infrastructure design. So those are the only things we need to be concerned with today. Product design is essentially the main designs where we're designing a product, right? So these are the kind of questions you guys have heard where they're asking, hey, can you design the backend for this application? Or can you design YouTube? Can you design a ride sharing app? We're thinking about how we would build a solution, starting off with a high level product that either exists or is kind of like a baseline of how we would design this type of product and we want to build a solution for it. And then infrastructure design. Okay. this is supposed to say infrastructure design. It's supposed to say infrastructure design, but infrastructure design is essentially, working with a system, a specific system. And we would be thinking about, how we would work with a specific system, a specific infrastructure, and it's more low level than the product design. And this is essentially like if we were trying to work with a rate limiter or something like that. So let me just fix this, guys. Thank y'all for bearing with me. Thank you, guys. I appreciate y'all. Okay, cool. And then I said we're gonna skip this. Okay, so just like doing regular interviews, right? Regular LeetCode prep, the resources tend to be the same as far as I'm concerned. LeetCode, Algo Expert, Hello Interview, Grokking the System Design Interview, right? Those are some of the top resources that we should be using. All right, so I want to go through this. I'm going to go through this kind of quickly. But this is the high level process of how we should be approaching these system design interviews, right? And a lot of this was taken directly from Hello Interview, which is a great resource you guys should use if you have not already been using it, where you essentially start with your requirements, you get the requirements, you start to build out the entities, you work on your APIs, your interfaces. We're going to skip data flow as well. But then you make your high level design and then you do your low level or your deep or design. You do a deep dive. So functional requirements, right? This is essentially when somebody asks you a question, right? We're going to go over a question today of designing a simple Bitly kind of thing, right? But if somebody asks you a question like, hey, can you build me an app that can, I don't know, do a to-do list, right? Can you build me an app that can store all my grocery needs for my grocery to-do list? The first things you need to do, or you need to get these functional requirements, which is essentially you asking questions of how a user should be able to use this application. So what features does it have, right? What features, if you're making a to-do list, a user should be able to type and add items to a grocery list, right? They should add items to to-do list. They should be able to add items to a grocery list. They should be able to remove items. They should be able to go back. It should be saved, right? Those are the kind of things that a user should be able to do. So that's how you think about functional requirements, is from the user standpoint. And after you're able to really ask these questions and get your functional requirements, you can kind of think from an engineering standpoint and get the non-functional requirements and think about, okay, what should the system be able to do? If I'm making a to-do list, how often is this person going to be adding text to it? How available should it be? Right? How consistent does this need to be? Is this something that needs to be accessible on like the cloud? Do they need to be able to access it anywhere, or is it just on their single device? Right. And you have to think about what should the system be able to do to make sure it supports that. And that is our non-functional requirements. Right. We have some examples here, right? Thinking about like more scalability, availability, right, of the application we're building. And then we have our core entities, right? So the core entities are like the central objects. That's the best way to think about them. This core objects, or the core data models that we need to have in our design, right? And again, if we're building Twitter, we have users, we have tweets, we have followers, right? These are things that we need to make sure we track all of them, right? Yeah. So after you're able to get these entities, we can really hone in on like what objects do we need to create. And it helps us because we can kind of start to think about like, okay, what data do we need? And what are the types of data that we need, right? We have a user. What kind of user information do we need? We need a user ID, maybe. maybe the user needs a password. Maybe the user needs a username, right? We have a tweet. Maybe the tweet needs text. The tweet needs a date. The tweet needs a bunch of different things, right? And it needs to be, the tweet should probably be linked to a user. And we could think about how we want to do that. We have, a follow. What is a follow? How do we track a follow, right? So those kind of things. The next step is creating our APIs. So on a high level, right? This is the system's contract with its users to guide our high level design, right? So if we're building a service or we're building something, we kind of need to think about how are we going to pass data from the user to our system and then later on to our database, right? But I guess for the most part, thinking about how we're going to pass information from our user from our front end into our service, into our system, right? We could think about creating an API, and there's different types of APIs, right? These are just a few here. REST APIs, which are really, really common ones that we're used to. HTTP requests, right? GraphQL, it's less common, but it's supposed to be really a lot more efficient. And RPC, right? This is high performance internal communication. I believe generally microservices communicating with each other, and microservices are, we haven't discussed what microservices are, but they are essentially, I guess, applications that run in the back on servers that can do a lot of that do have a specific job, and they tend to run on the cloud essentially. Do we have any questions so far, or anybody in the chat?
No.
Andre said Jake Paul. That's funny. Okay, cool. So the next step is we're working on a high level design, right? When we're working on high level design, we're creating a visual, and this visual represents all of the components. We're connecting it back to the requirements, right? We want to make sure we're consistently thinking about, okay, how are we satisfying the requirements? Are we meeting the needs of the API? Are we, using our API correctly, right? And then with high level design, the goal of high level design is for it to be simple. We don't want it to be complex. We don't want to add certain components to it too early. Right here, it says we don't want to add caches. We don't want to add queues. I know we didn't cover that. Some of you may or may not have already know about that, but we essentially want to keep it very simple, very high level. We want to talk about services. And again, services are, we can think of as just a piece of backend code that has a very specific job, right? You want to be communicating with your interviewer. You want to document that process. You want to think about databases. You want to think about like what kind of database on a high level would probably be useful for that. And then you want to, whiteboard it using different modern tools, right? And then the last part is our deep dive, and that is kind of where you go more in depth, and you can think about edge cases. You can think about how you want to refine your solution, right? You can think about things like scalability, and you can fix certain parts of the solution even more. Yeah, and I think one of the big things with system design is like the way that you interview, it does show the level that you're at, right? And I think you can be an engineer for many, many years. And obviously your understanding of system design, because you've worked on so many projects, is more in detailed, it's more in depth, right? This is something that you really do build over time, but the building that fundamental core is really what's important. And that's kind of what we want to focus on in the beginning. I'm not going to go over all of these core concepts, but this is what we talked about in the beginning. We just don't have time. Things like scaling, things like CAP theorem, right? Which is understanding trade-offs between, databases in a distributed system, locking, concurrency. We're not going to go over all of this stuff at all. Monitoring, right? Monitoring things, tracking the health, security, being secure. Technologies, we're not going to go over it if we don't have time. But thinking about things like storage, blob storage, the type of database you want, a relational, non-relational databases. Do you want a search optimized database? Load balancers? Do you want event streams? And then again, we're also not going to go over this. I don't think this is that important for us to go over today. But again, you see that this is something that for us to really go in depth is going to take a little bit of time. But I do want to talk about a few core strategies. And one of the strategies is really break down a problem, right? Anytime you're working on a problem, you want to make it smaller, break it down into smaller problems. And a lot of times, if somebody asks you, "Hey, how do you design Instagram?" Instagram has like so many features nowadays, right? Instagram has groups, Instagram has stories, it has posts, it has image filtering, it has accounts. One of the first things you need to do is prioritize. You need to decide what you're gonna build and what you're not gonna build. Because in an interview, you don't have time to cover everything. So you can talk to your interview about, hey, what's most important? What do I want to focus on? Um, and then you do a deep dive on something specific. And when you deep dive, having that core understanding is going to help you a lot, right? Also, understanding the current technologies, understanding best practices is going to help you a lot. Yeah. So I think that those are the main points that I wanted to hit. I want to go over a practice problem if we have time. If anybody has any questions, we can also do that. Any questions?
No.
Awesome. Anybody want to add any comments? Okay. Okay. So Andre, I guess you can take it away. We're gonna have to keep this short because I went way
Yeah.
over.
Yeah. I can go ahead and do that.
I went way over.
Do you want me to share my screen and
Yeah,
you give me
I have to
the
give you access.
system?
I have to give you access to share it.
Okay.
Do you have access or no?
I don't have access.
Okay, you should now.
Well, you have to stop sharing and then I can.
Okay, you should be able to share now.
Okay. Okay, let's share screen. All right. Awesome. Yeah. So do you want to take it away? Do you want to tell me what you want me to design and we can have a discussion there?
Yeah. I guess on a high level, right? How would you design DocuSign? I can't see your screen if you're sharing.
You can't see it?
No.
Oh man. Let me share again.
Okay. Thanks.
Here. Can everyone see my screen?
Yes.
Yeah, I see it.
Okay.
So
Awesome.
yeah,
Awesome.
on a high level, right? Maybe from like the most basic um what's it called? Dropbox. The most
Yeah.
basic version of Dropbox. Like how would you design it on a high level
Yeah.
in
So
like 5 minutes?
fair enough. So um I'm designing
Or-
Dropbox, but this is where we have a time constraint. So I want to prioritize what's super important. I want to, first of all, I want to get into the functional requirements, right?
Yeah.
So I want to be able to upload files, right? I know that Dropbox is for file sharing. I want to upload files. I want to share files. Um, you know, this is these are like two things off top of my head I can think of, right? On Dropbox, I'm uploading files and I'm sharing files with other users, right?
Mm-hmm.
So is that okay in terms of the
Yeah,
requirement?
that should be good.
Awesome. So, this is again, a time constrained sort of demo. What sort of, uh, I guess, let me ask you, like, how many users am I supporting for this design?
Let's say 1 million users.
1 million users. Okay. So about 1 million, we'll say daily active users.
Yeah.
million daily active users. And this system, uh, I'll kind of explain, but I would prioritize availability over consistency. Availability, if I prioritize availability over consistency, this system is going to generally be faster because we're not constraining the amount of resources to make sure that we have the same amount of that we're having consistent data that we're pulling from, right? So we allow ourselves to have more resources, even though the data on in the databases, like across the databases, won't necessarily be the same. Some won't be up to date, some will be up to date, but the ones that aren't up to date can be consistent eventually, right? So eventually consistent. So I'm prioritizing availability
Mm-hmm.
over consistency.
Mm-hmm.
That um and I want to upload like files that are, you know, maybe the amount of storage that I can handle, right, of files is probably it's technically unlimited if I use like a blob store. So that's
Okay.
okay. Um, and then what else there? What else is there? So 1 million daily active users. Maybe I want to make uploads fast, right?
Yeah.
So make uploads fast. Um, we'll say, I mean, it's happening in the background. We'll say I want to do like 4 MB per second or something like that. Is how
Okay.
fast. So fast.
Okay.
So- Okay.
Okay.
So now I want to go into my entities and, you know, we have a user, right? A user
Yep.
entity. We also have a file that we're sending, that we're like sharing and uploading. But then that file also has metadata. So we can say like file metadata as well. And then, this is essentially, this looks like enough for me to just go high level.
Okay.
So as long as that's, I'm ready to go high level with this.
Yeah, we could do it. Let's go high level with that.
Awesome. So, okay, cool.
I have a
So the
question.
first thing is,
I have a question.
Oh yeah, you have a question. We have a question.
yeah, sure.
Okay, so what about the back to the envelope estimations?
Could you turn up your mic or
It's not turned up?
yeah,
And
could you ask that?
can you hear me?
Yeah, I can hear you now.
Yeah, I was saying, what about the back to the envelope estimations?
Oh, you're saying back of the hand or back of envelope rather,
Yeah, yeah.
estimations. So I did that here on the non-functional requirements. Um, kind of. So for example, we have 1 million daily active users. An example of a back of the envelope, um, the back of the envelope calculation would say, okay, we have 86,400 seconds in a day, right?
Yes.
And this is the daily active users. So I would say something like 1 million divided by 86,400, right? And that would give me the number of transactions per second.
Yeah.
So whatever that value, so 1 million, we have 86. So
Like
think of
10.
this,
You can round it to 10 to
right?
10,
That's what
100,000.
right. That's what I was gonna do. So 1 million divided by 100,000 gives us a 10,
Yeah.
right? So it'd be 10 transactions per second, and that would be an example of the back of the envelope calculations. Um, this isn't super necessary to do.
Yeah, because I
Um,
was thinking about the necessity of that. Because
yeah,
sometimes I ask the question, what's the use? Obviously it's necessary to do the estimations, But sometimes I want to know the relation that exists between the estimations and actually the decisions we take
Right.
when we are designing. Because sometimes I feel like there's just um there's just a common pattern or a common idea that we have about the system and we just do it without maybe pointing that, okay, since there's maybe this number of users, that's why I'll use instead this this way of doing for my system. So yeah, sometimes I have the impression that yes, though we know that estimations are important, but they don't tie exactly the yeah.
They're not strongly relevant to the high level design. It's kind
Mhm.
of more of like, look, I can do math than it is showcasing like why you made a design choice. For example, if I know that I have 1 million daily active users, I'm
Mhm.
going to pretty much design for that scale. I wouldn't need to know that I'm gonna have 10 transactions per second, right? Like I would just know that this is like significant enough for like a high, like a large scale system, right? So you don't really need to do back of the envelope calculations. Um, it's kind of like a nice to have. But
Mhm.
as long as you understand what scale you're doing, that's enough. So if you're doing like a low scale system, so I'll even show you here. If I have a few clients, I have 10 clients using my system, right?
Yes.
And let's say we have this service called file upload service. So just be like a file upload service. And I have, this database, right?
Mhm.
So if I only have 10 clients using the system, like we just designed our system, like this is it, we're done, right?
Mhm. Yes.
But if I have 1 million users, this is gonna break, this is gonna crash,
Mhm.
and it's gonna cause a fire, right? And we don't want that. Um, So what we would do, and if it was like, let's say it's a mid-scale system, because there's tiers to it, right? If it's a
Mhm.
mid-scale system, this is also going to crash and burn the server, right? But there's not too much optimizations that need to happen. So for example, one optimization I would add if it was a mid-scale system,
Mhm.
just for this, for uploading files, right? I'm uploading files. I would add blob storage. So I'll use something like S3. That
Mhm.
this is a very simple blob storage, and this can store petabytes of data. This can store large amounts. This is essentially unlimited.
Mhm.
So instead of, so we would persist,
The
rather, we would store,
the
let me,
files inside the S3
I'm sorry,
that you store the files inside the S3.
exactly. So the files would be stored in S3, right? And we would have the file metadata stored in the database.
Yeah.
So the database will just keep track of like just about the file, right? The name of the file, the
Location.
author. I'm sorry.
The location.
So it would track it would have the location of where it is in S3. Um,
Okay.
yeah, because S3 is a file system. So it would have that. But yeah, but this is, you know, if we're talking about a mid-scale system, like we are doing a good job already, right? But let's now talk about kind of our functional requirements, sort of scale, and let's just kind of touch on the high level. So,
And we got a few more minutes.
okay, so what we have here is we just have a user through their like using a phone, using some device, right? And they're interfacing with the front end. This is the client. And then they make this request to upload a file. They click this button to upload a file and they pick their file and then they hit upload. Upload now goes to the file upload service. The file upload service is now going to process this, right? And this is all happening high level. just it processes this file. It gets the metadata and and stores the metadata in the database. And I need to also talk about what the database schema is going to be, or what the table schema is going to be for a file. And then the file upload service would, for now, at a high level, it stores the file in S3, right? So that's what's happening on a high level. And then we return back a response to the client saying that this was successfully uploaded, right? So
Right.
once you've done this, you're already doing really good. Talking about functional requirements, non-functional requirements, entities, and then you just explain what happened high level. That's already a strong like start. And then you're leaving yourself room for deep dives. What's your question?
I have another question. Yeah,
Yeah,
you mentioned that we should talk about the schema of the database, but I thought
of
that
the tables.
yeah, we should also talk about it in the high level because I thought that it was done instead inside the low level.
Could you repeat that last part?
Like you mentioned that we should do that during the high level design, right? We should mention the schema of the database, like the schema of each entities inside a database.
Yes, but you don't have to do that. So yeah, so here I have the entities, right? And
Mm-hmm.
before you get into the design, you usually won't have to like talk about what the schemas are going to look like for each of the entities. That's kind of like you're shooting yourself in the foot when you do that because you want to reserve as much time as possible to show that you know how to design the system.
Okay.
So it's just about that's what this so this stuff up here, functional requirements, non-functional entities, it's great, but ultimately the the diagram is what matters like the most. So the sooner you get here, the better. And you can, while at the diagram, you can talk about the schema. So here for a file has an ID, file has like you could say the user ID, right? And that's like a foreign key sort of thing if we had a user table. And then so ID, user ID, and then like location, as you had mentioned.
Yeah.
We would have the
The
uh
size is irrelevant.
that's right, that's right. We would have the size. Um, you know, you could say created at uploaded at, right? So all of that wonderful so this would be supposed to be file metadata, but we could just call this file. It doesn't really matter here
Mm-hmm.
because that's all we're storing in the database, right?
Database, yes.
And the file itself is being
The
stored in
S3.
blob storage, right? And then you could just imagine a user as doesn't really matter too much. User has an ID, a user has a name, and
Mm-hmm.
that's all we would really need for this at this level.
Mm-hmm.
So I talked about the uploading file at a high level, and then there's also sharing file at a high level. So I am a client. I want to share a file. So I think another thing because I skipped over something else I want to mention real quick. The types of requests that these are. So these are both post requests. And why? Why are they post requests? If anyone wants to take a stab at answering this, you want to go? Yeah, go for it.
Yeah, so the upload file is a post because you are actually writing data inside the database.
Okay. And what about the share files?
Now the share files, for that one, I'm not very sure why it's a post. Because when you want to share, because when sharing, it's the file is already inside the database, right?
Sure.
Yeah, so while I don't really see why the share file is still is a post request.
Okay. Um, maybe I'll talk about why it is, like maybe after. But I just wanted to get people to brainstorm, kind of think about why. But I'll share after why it is. And then we have the sharing files. So as a client, I want to send to the system that there are users with whom I want to share a file with. So then I send that info to file upload. I guess we could make a new service because maybe it would scale independently. Like if I wanted, usually you want to separate concerns of what's happening requirement wise. So that's just a general,
Like a service should have one job.
right. So a service should have one job, and we can call this the file sharing service, right? And file sharing is it's going to talk to the database. Rather, it's going to update to the database the users who are able to access a file. So,
Oh, yeah. Okay, okay.
so I would say something like, well, that wouldn't be really a good idea there. Probably want to make another table. Um, but you could say something like file access or something of that sort. So you could have
Yeah.
something like this. And file access is going to hold, it doesn't really need, maybe it does need ID,
Can
but
have the user ID and the file.
so yeah, a file access would say we have the file ID, right? We want a file ID. We want a user ID with
User
this.
ID, yeah, because the file access can be like the link between a file and the user, because a user can have many files and a file can be accessed by many users.
Right.
It can be that link,
Exactly.
one to many, yeah, that many to many relation. Yeah.
Sure. Yeah. That's a great way to think about it. So that's what's happening in the database. So we passed in the users and also the file with which we want to share to those users. And the database will grab that. We'll write new records into this file access table, specifying the ID of the file and then the ID of the user who has access to that. And then we return this, uh, you know, uh, we finish writing to our database. And then we return a response to the client saying that this was successful. So what I covered here is it's a very like high level, and it doesn't even begin to talk about what we could actually do to optimize this for a large scale system. But this shows pretty much everything that you would need to know for the type of data that the system is storing. So the type of data that the system is storing, the type of entities, right, that wrap that data, and what are we doing for the system? We're uploading files and sharing files. So that covers everything. But we could optimize this further. But having this already shows deep competency with gathering requirements, right? And this is what they care about. The interviewers care about seeing that you aren't worried about like sticking to a script. They love to see that you can interpret requirements and that you are, clarifying what you need, even negotiating requirements. They love to see that you're pushing back on them adding more complexity to the system. So always push back if you can as well. But yeah, keep it high level, always stick to high level, negotiate requirements, making as little requirements as you have on your plate as possible. and then design the high level system. And then only then once you're here, go into the deep dive. But for everyone who's mid-level and below, once you've done this, you've already won. Deep dives is like a nice to have at that point, most of the time. But yeah, are there any questions?
No, no, no.
Does anyone else have any questions or any comments?
Yeah, I now see for the comments, I now see why the share file is a post.
Oh yeah, that's right.
Yeah, I
So
now understand why.
the reason why share files is a post is because with REST APIs are simply a way to denote. It's a way to denote what the operation is. So post doesn't necessarily have anything to do with the database. This is just a way to communicate with the um, with what we're doing web-wise. So the API at the API level, Post says, I'm going to write something. I'm going to do something that's going to write to the service, right? So when I'm sharing a file, I'm writing to this system that this user needs access to this file. So it doesn't really mean that I'm doing a database operation. It just means um, I'm doing a API, sort of an API operation.
Isn't it like a path? Like it's almost like you're setting up a path for that file that's being shared.
Um, can you elaborate on that?
So basically, it's not a necessarily post, just like you said, because you're not writing to the database again.
Yeah,
But the Dropbox basically APIs will use a post, but then it will use in the body, it would use more so of like a path to the file that we're sharing, rather than saying, hey, we creating a file or we creating quote unquote like a document or whatever.
sure.
So that's how
Sure.
I'm imagining.
Yeah, exactly. So for example, just to kind of tie what you're saying. For example, if I had a GET request and I added a body to that GET request, well, we're just saying that we're just going to get stuff, and we added in some filters or we added in some data to help us get what we specifically want. But with this sharing files, I'm not getting anything. I'm telling the system, like, even though I'm adding in users, I have this request body. I'm adding in the users with whom need access to this file. I'm adding in the file like string or ID, doesn't really matter right now, but I'm adding in something to denote the specific file that I want to share. And it's an operation that's telling the system to add people together, to update this information, or to create this sort of um, to create this new state in the system. So it's like creating a new state, but it doesn't necessarily mean it's like a data like I that post means that we are always updating data or that we're always creating data. Just means do something to change the state of the system. A get is just retrieving. We're not really changing the system. Um, but yeah, I think, I probably could explain it a tad bit better. It's just been a minute since I've read on like REST API, stuff. But this is that's what those verbs really mean. Just means what are we doing at the API level? So, yeah. Okay. And I think Ramel is going to, I think, continue with, um, what he wanted. I think he wanted to break people into groups. I'm not sure, but we can wait for Ramel.
Yeah. I did want to break people into groups, but I guess at the moment we kind of we went over. We're about 3 minutes over, so it's up to you guys. Like if you guys want to stay, I would be happy to have you guys stay. Get into groups, work on these worksheets. We have like some practice stuff. It's not gonna be. We have like some simple problems, and then we have like some actual design work. So it's kind of up to you, what group you want to go in. And also if you want to stay here because you just have like more career advice questions for me, I'm happy to stay here. So let me know where you guys, I guess just put say one if you want to go in like more simple question group, two if you want to go like to the more advanced question. Um, and if you want to just stay here, I guess just don't comment, don't say anything, put in the chat.
I'll go ahead and stop sharing. Unless if anyone wants like a screenshot of this, or I mean,
Two,
I guess a screenshot, but uh, yeah.
one. Uh, I guess Alpha, what group you want to go in?
So it's almost like 10 p.m. here. I'm not sure I'll be able to stay that
Oh, no
long.
worries,
Yeah,
no worries,
yeah.
no
Why
worries.
don't, why don't we just have everyone in the same room? We could just do it easy.
True. Yeah, let's do the easy. Okay. Yeah, let's go over the easy questions. I guess I will share. And I put the link as well, right? So this is just, we don't have to finish, we don't have to go through all of these problems. Um, but this is really kind of just to help us out. So we're supposed to be working on this as a group. I don't want to, I don't want to give the answer away to these questions. So I'm not gonna say too much. But for our problem, we're essentially imagining that um, we're designing a URL shortening service like Bitly. This is a service that takes a long URL and it returns a short URL. And then when a user visits the short URL, they should be redirected to the original long URL. So essentially, we have this long URL input, like this link here, and then we're supposed to return this link here. And then when a user clicks on this link, they should go back to this original page. Also, I guess quick comment, if somebody actually wanted to just chat with me specifically, you could just like put it in the chat and then we can get in the breakout room if y'all like anybody had any questions for me specifically. But yeah, I guess we could I'll let Andre, you could lead the questions, I guess. By lead, I mean like just ask people. Cause
Sure.
yeah, because you have the answers. So yeah.
Okay. So I'm just want to just clarify these questions. Um, this is just kind of like walking them through like how they're designing high level, right? Okay, yeah, sure. Yeah, I can go ahead and ask them these questions. Should I pull up the worksheet and share, or what do you think? Oh, you're muted, by the way.
Oh, I said yeah, you can. Yeah.
Okay, cool. Awesome. So yeah, so we're designing a URL shortening service, and it should take a long URL and return a short URL, right? And when a user visits the short URL, they should be redirected to the original long URL. Um, so this this is a relatively straightforward, unless if there's any confusion, definitely let me know. But this is just saying we're going to store a long URL and get back a short URL, and then that short URL. By using that, there should be some processing where we get to the URL we need to get to, right? The original long URL. Okay. So first question is, what are the two core functions this service must perform? Oh, this is
I see.
yeah,
Right.
that's correct. Let's see. Which of the following is an essential functional requirement for our URL shortener? And take your time when you're thinking about this stuff. Take your time, guys.
I guess it would be B.
Um, I would say, yeah, if I'm looking at it, service, the system must handle high volume traffic. Service must generate a. I mean, yes, that's right. We need a unique short URL, right? A unique one. Or else we're gonna have, um, you know,
Collisions.
right, exactly. Which of these is a key non-functional requirement for our service?
Service must be highly available and have low latency.
Right. I mean, these questions, yeah, yeah.
Yeah, because A and B are more functional, I think.
Yeah, those are functional requirements.
Mm.
Exactly. What are the two essential pieces of data? And oh, could you say your name for me, Leopold?
Yeah, Leopold.
Just Leopold? Okay. Let's also try to uh just like if you want to kind of let others just like see if they can answer,
Okay, okay,
just like mix it up. That's all. That's all.
okay.
Yeah. What are the two essential pieces of data we need to store for our service to work?
Short
That's
URL and long URL. The option
right.
C.
Right. Exactly. Okay.
Nice.
What primary service or component is responsible? So what primary service or component is responsible for redirecting users from a short URL to a long URL? And this is kind of like this question is a just following a microservices pattern, which, by the way, microservices are um, just single responsibility services. That's it. Microservice is a single responsibility service, and they're used in distributed systems. Um, so anyone have the answer for five?
Mm,
We can all say it on three, okay? On the count of three. One, two, three. A.
B.
A.
B.
A-
A.
Wait. For redirecting users. So service are responsible for redirecting users from a short URL to a long URL.
Mhm.
Well, somebody has to say B, man. Why is it not? You gotta say why it's. You have to at least say why it's not.
Oh. Okay, fair.
Yeah,
Okay,
why does it
guys.
not be?
Right. So this is a B says a URL generation service that creates short URLs. But this is not the functional requirement or the thing that like this is saying. This is saying redirecting users from a short URL to a long URL, right?
Mhm.
So a generation service does not redirect users from a short URL to a long URL. A
Mm.
monitoring service does not redirect users from a short URL to a long URL. If a monitoring service checks system's health, that's not the same thing as redirecting users, right? So a
Oh,
dedic oh, what's up? What's up?
What
continue.
what if okay.
Sorry. I thought it was B, so I couldn't share my answer. Then now I got a clarity. Okay, it's A. Thank
Yeah,
you.
Okay,
yeah,
I have a question.
yeah, yeah. Yeah.
What if B instead set a URL like let's say a reverse generation service that creates the long URL from the short? What would be the answer now?
I don't think I didn't really understand your question.
I mean, what if answer B, right, was saying something like a service that converts back the short to the long?
So the definite so with generation,
Yeah,
uh
regeneration.
yeah, so if you go from a long URL to a short, or sorry, if you go from a short URL to a long URL, that's not generating. Um, that wouldn't no, it wouldn't be considered generating. It would just simply be considered like undoing, not undoing the generation, but it's the opposite of the generation, right?
Yes. Yes.
Generation says, oh yeah, go for it, man, go for it.
Yeah, so if it was that in that case, right, what would be the answer now between A, B, and C?
If you're saying the question asked for generation to
No,
generate,
if I modify the answer B so that it undoes, right? It undo the conversion from long to short in order to get back the long.
I mean,
Will the answer now be A or will the answer now be B or will it still be A?
if you want to convert from long to short, the answer would be B. If you want to convert from long to short, answer is B.
No, it seems you're not understanding what I'm saying.
Sure,
So
sure.
my question is, since right now B is saying a URL generation service that creates short URLs, right?
Yeah.
It's not answering our question. Now I want to change this answer. If it is instead um, a service that converts the short URL to the long URL.
So you
So
want to
what?
change the answer.
Yes,
That creates a short URL, right? So
that
tell me
co-
what you want me to write here.
um, a service
Yeah.
that converts the short URL to the long URL.
Okay. That converts the short URL to the long. So converting the short to the long. This is redirection.
So it is the same as A.
Yes, exactly.
Because I was thinking of A more like AOJ converted the long to short and now I just store in the database just for retrieval. But in the second case B, I have to carry out the process again of regeneration.
Sure,
I
sure.
think that's a good point, but I think like I guess at that point it just depends on what the service actually does, you know,
Mm.
at that point. But I think I think that's a good question. And the naming of this question could probably be the most thrown off part by saying, you know, redirection service or generation service. Like if it's not absolutely, you know, redirection, or if it has multiple roles or responsibilities, then I think
Okay.
it could kind of confuse the question. But I think that's the main reason why we really naming is important and making sure a service has one responsibility is really important. So there doesn't create confusion.
Right.
Okay, thank you.
Welcome.
Of course. So as our service grows and receives millions of requests, what component is needed to distribute traffic evenly across our servers to prevent a single server from being overwhelmed? So this service is growing. Now I'm going to horizontally scale out more servers to handle the increasing load from our clients, right? So we started with, and I'm going to just kind of illustrate this out a bit, just to make it easier for you guys to follow it. How do I move this thing? Okay, right there. I have this service, right? And clients are hitting the service, right? So we have clients hitting the service, but now we have too many. So now I'm going to add one more in, and I'm going to add another, and I'm going to add this service in. So now we have 4 services. But the problem is we're still pointing to this. We need something in between our clients and these services. So what is this thing here that is in between our clients and all these and a bunch of these services? What is this thing?
You want me to go or?
Yeah, man, anyone answer. Anyone.
Yeah, so since we're talking about servers here and we basically scan them horizontally, I'd say a load balancer to be able to redirect traffic of users pretty much throughout, like evenly to kind of like distribute them.
Right. So that's correct. So load balancer. That's correct. So a load balancer is going to help you distribute traffic evenly, right? Um, and there's one simple algorithm that you should just know about, and that's the round robin, right? And what does round robin do? Anyone want to take a hint what round robin does?
See, this is the part where so round robin, if I'm recollecting correctly, doesn't round robin basically take the number of users that are hitting a particular service and divide them by the number of servers? Or am
Doesn't do all
I
that.
off?
It does. It's even simpler than that. Even simpler than that.
Dang it. See, I need to review my notes. Yeah, I'm off there.
Yeah, go for it, Leopold.
Okay, so the round robin does what it does is um I have a number of requests, I have a number of things that I need to do, and I also have a number of workers or a number of services. So what I do is um maybe starting from service one to service three, I give one work to each of them. And like sequentially, right? From sequential, I give a walk to one, I give a walk to two, I give a walk to three. Now I come if I still have some works that I need to do, I come back to work one. If he's done, I give him another work. Now I go to work two. If he's done, I give him another work. So that's how I'm doing. So that's actually round robin.
Let me write that. Sending requests in a um let's say
Sequential.
sequential round
Yeah.
control circular order.
Yeah, circular. Yeah, that's the word.
Yeah. So that's all round robin does. It sends requests in a sequential circular order. And that's it. Just know this and you're good. Just say round robin whenever you bring up a load balancer. And you're pretty much golden. Um, you won't really need to be involved into like the load balancer unless you're like a senior, right? They're not gonna like ask you specifics on this stuff. Um, let's go back to the worksheet. All right. Is everything is everyone good on that? That like what I had shared there?
Yes.
Awesome. Awesome. Okay, so this next question. Given the large volume of read operations, okay, redirects, right? So I'm reading using my short URL. I am basically reading what my long URL is and redirecting to that. So given large volume of read operations and the simple key value structure, short to long, which type of database is generally the best fit for this problem? And this might be, if you don't really know about databases, this might be like, I mean, it might be intuitive, but at the same time, this might be hard. And there's also another answer down here. So let me highlight all of these, okay?
I would say C.
Okay, so why would you say C?
I would say C because I'm interested into the NoSQL because it functions a bit like a hash table, like a key value, yes. But following that reasoning, I would have choose B, but the radius is not mm, like it is temporal. Radius is temporal, right? Not
Temporal.
permanent. Is it permanent, radius?
You said permanent? I'm not too sure. I mean, Redis is usually in memory, if that's what you're asking.
Yeah.
Yeah, but is it permanent or it means it's permanent, right? It means it's temporal, right?
Um, I don't really, I
Yeah,
don't
I
really,
mean, I guess what he's asking is that because like typically Redis is used as like I want to say
oh,
like a cache.
I know what you mean now.
So
Never mind.
I think that's the question he's asking. But
Yeah,
I
yeah.
think looking at this question here as one thing that I'm looking into this question is the fact that we have large volume and we need to process these things fast, right? The read operation has to be fast. So I think B would be more suited because of the fact that we need to have like a super fast read operation.
Okay. Yeah, I see.
That's the answer I would go. I don't know what's the final answer, but that's the answer I would go. Just because of the fact that we're dealing with large volume of read
Hmm.
operations.
And one more thing I just want to add here is like a simple key value structure. So for option B, we have NoSQL key value stores. So we can relate that way.
Exactly, yeah.
Right. And DynamoDB, just want to point out DynamoDB is an example of a permanent like data store that holds key values. So Redis isn't permanent, it is in memory and it doesn't store stuff on disk. DynamoDB stores stuff on disk or
Yeah, yeah. So yeah, I understand what they said and I'm okay with what they said, but uh, since it is not permanent, right? That's why I was thinking more in this direction that imagine that the system goes down. I will need again to convert all those long URL to a short URL before storing them in Redis. So that's why but that's not efficient, right? So that's why I thought of storing them inside the MongoDB because it's permanent.
right. Yeah. So that's a good call out. And yeah, Redis, if you had to choose between Redis and MongoDB, I would definitely pick MongoDB. If you had to choose between DynamoDB and MongoDB, I would definitely pick DynamoDB here.
Yeah.
I think so DynamoDB, Cassandra was written here, but Cassandra is not I don't think Cassandra is key value, but DynamoDB is key value. And it's you know, this is this is the optimal choice for um a key value structure with short URL and a long URL because it is persistent and it is a key value data store.
Okay. Thank you.
I didn't want to cut you, but I think I do believe Cassandra is key value, I think.
Cassandra is key value?
Yeah, I do believe.
Snap. Okay. I thought Cassandra was a wide column. It's like a column type of type of database. Like it stores data in columns, something like that.
I'm looking online and I'm seeing something saying it can be used as a
Okay, sure,
but
sure.
it's not a simple one, but it can be used
Yeah.
as one.
Okay,
So yeah, I agree. Remove Cassandra. Thank you, because that is kind of confusing. The
yeah,
question was confusing throwing Cassandra in there.
sure, sure. So to handle, so good call out by the way, Leopold, on like the temporary versus permanent or persistent verse in memory. To handle the high volume of reads and reduce the load on the database, what component should we add to store frequently accessed short URLs and their corresponding long URLs in memory? So we already touched on this.
Mm. So the
And
type,
yeah, so you guys want to say the answer? What the
A.
answer 8 is? Okay. Anyone else want to, does everyone agree with that answer or,
What was the answer?
well, what do you think? What do you think the answer
Oh,
is?
I'd say A.
You say A? Okay.
Yeah, but I just didn't hear. That's what I was asking.
Okay, okay, okay. Yeah. But the answer is A. Yeah, the answer is A. When generating short URLs, we can create a unique 7-character string if we use a random hash function. What is a key problem we might face and what is the best solution? Okay. So I have to read this question too. When generating short URLs, create a unique 7-character string. Okay, we use a random hash. What is the key problem we might face and what is the best solution? Okay. So take your time, guys, and then just kind of hold on to the answer, and I'll call on someone. Okay, does everyone have an answer? Or does everyone have an answer for number 9? Should I pick someone at random, or does someone want to be brave?
Mm, so basically, I'd say B, because with this problem, I think one of the fundamental bottleneck with hash generation, typically the collisions are always possible. And I think we need to, in this case, we need to handle that, right?
Excellent.
Um,
Excellent.
so yeah, B, I'd say, but if someone has a different one.
Well, B is correct. So you had textbook, mentioned hash collisions, right? Um, and you know, if you're taking a hash using a random hash function. Now, if this hash function isn't very good, you're going to run into a lot of hash collisions. So for example, if the hash function is like modding by 100, right? Um, and we produce a hash from that, then you could easily run into a hash collision. And if you have that, right? So let's say you have a hash collision, then there's ways to fix it, but um, if you use the hash table. So let me just kind of show you guys. Let me set the canvas. So if I had like, this is my hash table, right? And then should I? So let me do this. So, so this is like my hash table, right? And I mod some random string or something by 100. It somehow works. We mod it by 100. We truncate something and we place them here. At some point, we're going to collide. But then we can, if we have that collision, we can just store, how do I, that's weird, but we can store um like something new. So if we had like um 20 here or something, and we still got we got another 20 from modding, right? From the hash, another 20. Then we can say something like maybe 20 and add a one or something, and then 20 add a two. So there's ways to, get around the hash collisions. But as you can see, we can't just overwrite the collision. We have to append or something. We have to do something to make it unique, right? So that's
Mhm.
the general idea. We got to make it unique. So that's what happens with um, hashing and a hash function that's not very good. However, if we remember, it's 7 characters, 7 character string. When you have characters, there's 26 characters. And then you can also use letters. So you have 26 characters and 10 and I said letters, I meant digits. There's 26 letters and there's 10 digits. 36. So that's 36 raised to the 7 because each placeholder, each place can have 36 options, right? So 36 raised to the 7 is a pretty large value. But that could still, if not, if not using a good hash function, you're going to run into a hash collision. And that's pretty much it, right? Hash collisions, use a data structure that helps you with that, or just use a better hash function. So 10, our service is so popular that the single database server is overwhelmed by write requests. So those write requests are creating new short URLs. Which of the following is the best solution for handling the increased load and why? So I have a single database server, overwhelmed by write requests. So the server, uh, yeah. Oh, so I have the single server. It's overwhelmed. It's getting red, right? It's about to burn. What are we gonna do?
Can you repeat the question, please?
Sure. So um I have this single database server,
Mm-hmm.
right? And it's overwhelmed by write requests. Which of the following is the best solution for handling the increased load? So we have this server and
Mm-hmm.
a lot of write requests are coming, right? A lot. And this is not good, right?
Hmm.
Mm.
This is too much load on the server. What can we do to make our system um, more tolerant to or more scalable rather to the amount of load that's coming in?
So the
So
first thing, uh, can we talk?
What's up?
Yeah, I mean the first thing I see is we can create like many database servers.
Mm,
and like we replicate now the data to
nice.
all the nodes so that we can now like distribute now the different requests to the different database.
Mhm.
So to create like a kind of parallel computing, like, yeah,
Yeah,
so that each request will be served and no database will be like overwhelmed.
okay, okay. So you're talking about like horizontal scaling then, right?
Yes,
For parallel computations,
yes,
horizontal scaling would allow that to happen. But also a single server itself can have multiple like threads and multiple things connecting. So you could technically on a single server have parallel computations, but with horizontal scaling, it distributes this concept. The concept is called throughput, which is just number of um, requests per second. You could say concurrently, not per second. It's concurrently. The reason why throughput is just the number of requests at at some unit of time that is running on the system or that is writing or reading, just calls. Number of requests that are using the system at once, right? And that's what throughput means. We just have this load. And if the load increases, then when we horizontally scale, we're saying our throughput increases, right? That's what we're saying. And there's this other metric called latency. Latency is how long a request takes, right? Throughput, number of requests that are that are running concurrently, and latency is how long that request is taking. So these are really important for like a server for rather for the system itself. And you use throughput and latency as measurements for your performance and your scalability, like how scalable a system is, um, how good the performance is. So throughput and latency are what we care about. And horizontal scaling improves throughput and latency. But also, you don't always have to do horizontal scaling. We could have also done vertical scaling. Vertical scaling is to improve um, the hardware on the single machine. So we're improving the actual hardware itself on the one machine. And
But
this,
but don't you think there is a limitation factor when it comes to expanding? Because I agree with with what you're saying, because I think I understand you kind of laying out the foundation. And I think for me, when I'm answering these questions, I always like to break it down to what you were saying.
yeah,
First identify the vertical way of doing it, by adding more compute, more power, and things like that.
right,
Then see the limitation based on the requirement we have, and then we can move to the other one. But
right.
yeah, I guess the question I was asking was just to kind of like maybe if you can touch on um, the limitation factor on the vertical
A
scaling.
vertical?
Yeah.
Yes, of course, man, of course. So a limitation is, I mean, we could speak generally about it, but it would help to know about what the limitation is in respect to a scenario. So I'll go generally first. The limitation with vertical scaling is that it to scale your system vertically, it tends to cost more, and it costs more than if you're doing horizontal scaling.
yeah,
And it does have a limitation with how much compute power, storage power that you can have on that single machine. So it has its upper limit, and it's not generally used in large scale distributed systems unless you are upgrading it with a with data that is ACID compliant. SQL, like SQL data. Data that has to be ACID compliant and it's easy to manage on a single machine. This is when you would use vertical scaling. So like if you have like a server at your company and this server is managing all the users that use this company. And it's like, okay, now we have to grow, this our company is growing. But like it's not like too much growth. We have a lot more users using our platform. We should just vertically scale our server. Let's add more resources to our server so we can support more users on the system. And vertically scaling in that scenario is the perfect answer, right? Better than horizontally scaling. Unless like, you're okay with the added complexity of making sure that you have to have, ACID compliant. Yeah, that's we don't have to get into ACID compliance, but it's essentially the ACID just means making sure that our data uh, is um, make sure our data is consistent and that the database is always in a valid state, that there's no transaction that will um, make the database make the data in the database um, like incorrect, right? That everything is a valid transaction and that no transactions are messing with each other, right? Atomicity, right? Um, so ACID is just like about we have strict standards with our data. So when you think about ACID, think about strict standards with our data. So horizontal scaling adds more complexity with that.
Specifically for SQL though, specifically for SQL.
Right. So no SQL data, don't worry about ACID compliance. You can horizontally scale to the moon if it's no SQL. But vertical scaling with SQL, with SQL, using SQL, you're gonna want to like try to vertically scale before you horizontally scale. So yeah.
Hey, also I wanted to add, guys, I know we've been way over. If you guys have to head out, feel free to head out. I know some people are on the East Coast.
Yeah.
So yeah, if you guys have to, feel free. No worries here. But if you want to stay, you
I mean,
can as well.
why don't we like go ahead and stop here anyways because I do
Yeah,
have to get going.
yeah, that sounds good.
Uh,
That sounds good. Well, yeah. Did anybody have any other questions or anything they want to bring up? Bro, Andre, thank you so much, man. We appreciate you. We appreciate you going over that. I should have been stopped the recording.